Hello and welcome to my second submission for the Web3 Infinity Hackathon. This is called Block Qualified, and what this is about is a way to get credentials by solving multiple choice tests directly on chain. So this allows you to solve tests privately and verify them trustlessly, all powered by zero knowledge proofs, ZK snarks, right? So the idea with this is really to enable a way to create and obtain credentials or in a decentralized manner, right? So how you do it is by solving this multiple choice tests, which get pinned on IPFS, and what you do is you send your solutions on chain, but to ensure that someone cannot come in after you and look at your public transaction and copy it and gain the same credentials, this solution gets obfuscated in a clever way, using zero knowledge proofs and a bit of fancy math. And so what you can do with this is essentially prove that you know about a subject, basically. So let's just play around a little bit with the tab. So if we go on over to the create section, we can create our own credential here in two simple steps, so we can see. So first we need to define it by giving it a title, a description. I'm just going to give it some filler values so you can see how this whole thing works. So let's just say question 1, right? And so we have here, we can write a couple of answers, and the cool thing about this is that it actually supports Markdown. So if I click here on preview, you can see that it renders the Markdown, so that this will actually get rendered afterwards, as we will see. So we just define a couple answers, answer 2, right? So we just define this one to be the right one, and we go ahead and pin it to IPFS. So every test gets actually pinned onto IPFS, and as we can see, we can copy it, and we can actually open it up here on a new tab, and we'll look at it in a second. So that's what actually gets defined here. So every test gets actually uploaded onto IPFS to maximize decentralization, basically. And this answers tree root here is basically just a fancy bit of math, which is what ensures all the privacy, all the zero knowledge proofs going around. So if you're interested to know a little bit more about that, there's a more comprehensive explanation in the README file. So just give it a test name here to create a new credential. We can also give it an NFT pass, which is required for owners to solve it, a deadline for it, and max number of credentials, and a price to the first solver. So let's just confirm here this transaction. And so basically, if we go on over to the browse file here, browse section here, we can see the tests that are being defined. So let me just open this one 1 second, which, as you'll notice, is more pretty than the one I just defined. And here you can see that the Markdown gets actually rendered, right? So you can see here that there's this image embedded inside of this question 10. And so if I just try and solve this right now, what's actually going to happen is it's going to try and generate the proof that, well, basically proving that I know a solution, which is going to be the wrong one, which is not that one. And to generate the proof is actually using the necessary files which are hosted on IPFS. So that ensures maximum decentralization. What does that mean? So anyone can come in. They don't even have to interact with the front end. They can just get those files from IPFS, generate their own proofs, and get their own credentials if they wish to. They don't even have to interact with the front end. So the idea with this is to ensure a fully decentralized way to get credentials. But as you can see, this is not the right solution. So I have here in another tab the actual right solution. So if I just click here on submit, it's going to generate the proof much the same way, fetching those files from IPFS, and it's going to allow me to send the transaction here on MetaMask. I am going to confirm it, and as you'll notice here in a second, this number of trophies here, which is just the one person that solved this, will increase into 2. So this is actually the test that we just defined earlier. As you can see, it gets pinned onto IPFS, and what you can do after that is you'll be able to render it and look at it quite natively. So these are all the existing tests. There's a couple of test ones. This one is quite interesting. If you're interested in the project, I invite you to try and solve this one. And this is the one that we just defined with the test name, test description, and well, this is what gets rendered. So that will be it. Thank you all for watching, and have a nice day.